best thing about the Deep Foundations Institute is the collection of engineers, contractors, material equipment suppliers, and academics. And so bringing everybody together means the stuff that we get done is useful and is immediately applied and is not in some out there academic corner, or it's not promotional to one type versus the other. It's really a true collection of the best of this industry.
Membership of the DFI has many benefits. As I said, there's, for the younger members particularly, there's a wealth of knowledge within the DFI's archives, if you will. The magazines, the journals, the publications. We have this organization called One Mine that we subscribe to, where there are literally thousands of documents on all aspects of deep foundation construction, design, etc. So from that point of view, it's a very, very important resource that comes free with your membership.
Learning about technical advancements, again, seeing what projects people are up to and what solutions other engineering firms have come up with, and then the networking opportunities that we get at the in-person meetings like this conference.
I think the technical committees is just another great way to get involved in DFI. You meet a lot of people in the industry that are very influential and important. They make a lot of decisions that we live by in the industry. So when you participate in a committee like that, you can see firsthand how design and construction is kind of sculpted. So it's a lot of fun, and it's a worthwhile investment.
It's an organization basically that guides not only the principles of what transpires in the Deep Foundation Institute or industry, but also brings everybody together to discuss common problems and provide solutions.
Greetings to all the participants of this webinar. This is Pranav from DFII of India office, and I welcome all of you to this DFII of India webinar series on practices for efficient subsurface characterization. This is the series, and today we are having the second session under this webinar series. So I welcome you all from all the parts of the world that you are joining. Recording of this webinar is prohibited. Online webinar recording will be available on DFII of India YouTube channel in approximately 2 weeks' time. So we request you to focus on the discussion rather than recording or taking notes. You'll have all these things available on YouTube. So anytime during the webinar, you can ask your question to the presenter. You have a Q&A tab. You can enter your question here, and all the questions will be taken after the presentation in a separate Q&A session. And we would like to mention all the participants. We have more than 280 registrations for this webinar series, and they are from 14 countries. You can see the names below. We welcome all of you to this webinar. Now today's program. And this is the sequence. First, we have introduction of the speaker, then presentation by the speaker, that is Mr. Sorabh Gupta, on gold level geotechnics for high-rise building. Then we have Q&A session, as I said, and after that, closing of the webinar. So now, without further ado, I'll welcome today's speaker, Mr. Sorabh Gupta. He's director at Cengrs Geotechnica Private Limited. He's also Vice Chair of the DFII of India Committee for Geotechnical Characterization for Foundation. His topic of presentation is gold level geotechnics for high-rise building, as I said. And a few lines about Mr. Sorabh. He's a soil and foundation expert with over 18 years of experience in geotechnics. Okay. Sorabh Gupta holds a BTech from IIT Delhi and a MS from Stanford University. Under his leadership, Cengrs has delivered precision geotechnical solution across more than 6,700 projects in Indian subcontinent. That's a huge number. His work emphasizes data-driven decision-making, optimizing foundation design, and advancing the geotechnical investigation field with precision testing. With this short introduction, I welcome you, Sorabh Gupta sir, and I request you to carry on with the presentation and share your findings and knowledge with the audience. Thank you.
Thank you so much, Pranav, for the kind introduction. Please allow me a minute to share my screen and let me know if this works well.
Yes, it is fine.
Pranav? All right. Great. I'll jump right into it. I've been given 40-45 minutes by Pranav. I will try my best to complete within that time. So the topic of today's discussion is something which we call gold level geotechnics for high-rise buildings. And I'm Sorabh Gupta with Cengrs. Very quickly, I would like to introduce our company. Cengrs is actually an acronym for civil engineers. So C for civil and ENGRS for engineers. A lot of people ask me this, so I always begin with this. We are a 35-year young company with a staff of around 150 people. And as Pranav mentioned, we have, we like to believe there is no corner of the country or the subcontinent where we have not gone ahead and dug holes. So we have a good number of projects, around almost 7,000 projects, which we have completed in the last 34 years and counting. So we usually turn around 250 to 300 investigation jobs every year as well, of various sizes. In terms of service offerings, we are essentially everything to do with soil and foundations is our focus. So apart from investigations, geotechnical and geophysical investigations, we also carry out some geotechnical consultancy projects and also deep foundation testing works. Of course, everything requires foundations. So whether it's energy sector, power plants, nuclear power plants, wind, transport infra, water infra. So our project portfolio is kind of diversified across all these sectors. And we are blessed to have had the experience to work on various kinds of projects and learn from them as well. This is a quick map of the same thing. As I said, we have covered most of the Indian subcontinent so far, and possibly have one of the larger private subsurface data banks in the country as well. This is us. The company was founded by Mr. Sanjay Gupta and Mr. Ravi Sundaram, and I'm Sorabh Gupta. I'm the relatively new joinee, and we are supported by a fairly good and a strong team with us who are helping propel the company forward in the right direction. We do believe very strongly that professional associations such as DFII are very important in the life of an engineer. It's very important for all of us to actively participate in these kind of forums, share knowledge, learn from each other, support each other. And so we always encourage, DFII has been an excellent organization for the last many years now. So we always encourage people to and engineers to get out of their wells and actually talk to each other on a common platform, share experiences and knowledge. So this is something we are very active and very vocal about. Just a quick news. I think we are one of the first companies in the country. We have extended the scope of our accreditation, NABL accreditation, to now cover the full range of our field testing as well. So all the conventional and as well as advanced tests which we carry out, both geotechnical and geophysical, as well as file testing, all of these are now covered in our scope of accreditation. And I think this is one good step in the right direction. Always we encourage all investigation companies to work towards this direction, and so we can improve our service offerings, improve the quality of our product. Let's jump into what we have to discuss today. So I mentioned gold level investigation. This is not a standard term. This is sort of something which, with some inspiration we have coined. So we have defined some levels of geotechnical input from bronze to silver, gold, and platinum. We like to say that you get what you pay for in terms of what these levels are. And I want to give credit to engineer Chris Haberfield of Boulder Associates, who actually introduced us to this concept in one of his talks. So the slide is borrowed from Chris. It's essentially from bronze to platinum level investigations. What we are basically talking about is, without going into the details of the slide, is as your structures get more complex, as your loads increase, and or as your ground conditions become more complex or more challenging, the requirement is to move. A bronze level investigation could simply be, for example, a small building in a fairly well-known geology, where we can possibly get by just carrying out a few shallow boreholes and using, conservative rule of thumb kind of geotechnical design. And this is fairly good because it's for such structures and for such projects, this could be fairly inexpensive, and the risk involved would be high, but we can get away by giving a conservative design to the project owner. On the other hand, these days, such projects are few and far between, and most of the time, as land is becoming short, as our projects are getting more and more ambitious, we are moving more and more towards a situation where our demand on the ground is increased. And so what falls upon us as geotechnical engineers is to up the game to meet the requirements of the project. And a gold level investigation, for example, could mean a combination of not just conventional borehole investigations, but also in situ testing, better lab testing, some site-specific design parameters, better analysis, and serviceability-based design. Now, of course, while we are able to, by going with a gold level investigation, while we are able to mitigate risk to the project, the cost of the investigation itself would naturally be higher as compared to the cost of a bronze level investigation. That said, and the studies have shown, and I think most of us who are geotechnical engineers are aware, that as we invest more in proper ground investigations as a percentage of our project cost, the cost overruns in the project are well documented, that as you invest more in the ground characterization, you have some saving in terms of reduction in cost overruns, reduction in foundation, in construction timing, in construction schedules, and so on and so forth. So and we will see today how such an investment it's almost a no-brainer, because the kind of return that you get from proper investigations is phenomenal for almost every kind of project. Jumping into high-rise buildings, this would be, I'm breaking this presentation today into 6 parts. So while first we'll just discuss about the codal requirements, one slide, we'll talk a little bit about the tools that we are using. So we'll talk about better SPT, rock drilling, in situ testing, foundation testing, and finally, I'll try to share 1 or maybe 2 case studies just to illustrate how these techniques are used for better geotechnics. A quick overview, and this is just one really busy slide on codal requirements for high-rise building. For those of us who may not be working on high-rise buildings day in, day out, there's been a lot of movement in the codal requirements in the right direction, of course. So now we have a new code, which is IS 16700-2023. This code is specifically made for what they call high-rise buildings. High-rise buildings here being defined as buildings which are, height is between 50 meters and 150 meters. So roughly around 15 to 50 floors. So this code becomes applicable. In terms of this code is fairly good, and largely, although it covers a lot of points for structural engineers, I picked out a few clauses relevant to geotechnical engineering, starting with the scope of investigations. So the code refers back to 1892-2021, the 2023 code. And 1892 clearly says that if you are coming up with high-rise towers, then you require 3 boreholes or 3 tests per tower. The depth of investigation should extend to at least 2 to 3 times the width of the foundation in the case of small isolated foundations or open foundations. and at least 1 to 2 times the width of the foundation in the case of raft foundations. In the non-tower areas, typically a grid of 30 to 40 meters is recommended, say in the non-tower basement areas for ground investigation. And I also am pointing out specifically 1892 clause 6.1, which, as Dr. Partha Sarthi shared last time as well, is the code is moving towards preference for the use of automatic trip hammer for SPT. The code also talks about how if you are coming up with a raft and tall buildings, then the code also suggests or sometimes recommends carrying out soil structure interaction studies to better understand the distribution of K values at the foundation level, and for better soil structure design. What is also very nice, I think, is clause 11.3 of IS 16700, which now talks about mandates carrying out settlement and pressure monitoring for foundations. And I think this is great. Instrumentation, I think, is the future and should have been the past as well. So it talks about the need for settlement monitoring for raft, installing pressure pads below the raft, and also talks about instrumenting piles with strain gauges, so you can actually measure the load transfer to the piles. I just want to mention IS 1893 Part 1 is currently in the wide circulation, and hopefully it should be out soon. Once it is, apart from changes in the seismic zonation, there are also expected to be changes in how we decide the site class. So once this code comes into action, I think rather than using SPT values for site class determination, we will be needing to carry out shear wave velocity tests at every site to get the VS30 values and to define the site class based on that. A little bit of technical, I want to talk about SPT. This is a very oft discussed topic, but I want to keep driving on this. When we say SPT, that's a standard penetration test. And I think most geotechnical engineers worth their salt will agree with me when I say that there's nothing standard about the SPT. And this is something we're trying to educate customers over and over again. Obviously, your SPT number depends on so many parameters. It depends on your drilling and borehole technique, the type of equipment used, the test procedures used, the energy delivered, the overburden stress, and the ground conditions. So chances are, if you carry out SPT alone, using different equipment, different teams, or different kind of hammer arrangements, chances are you are going to get different end values. So I strongly believe that relying solely on SPT end value for geotechnical design may not be the smartest thing to do, because sometimes you could err on the side of caution, sometimes you're erring on the side of risk. And it's very important as engineers, especially as geotechnical engineers, where we're dealing with such a complex material. It's important to have data collected from various sources and corroborate the results before we make the decision on the design profile and on the foundation performance. So, I mean, obviously, one solve is to extend NABL accreditation to field testing. So that step we have taken. So now the hammers themselves, which are supposed to be 63.5 kg, are calibrated. At least the weight has to be accurate. The second improvement, as I mentioned before, is, and I think these are very inexpensive improvements which should be mandatory for all investigations, is the use of automatic trip hammer for SPT so that the height of fall is consistent. The third thing, and I think we have been talking about this, and this is becoming quite popular, is we recommend carrying out SPT energy measurement for every project, for every rig or SPT arrangement being utilized on that project. I'm happy to report that the last maybe year and a half or 2 years, we have made a lot of effort. And I think today, 70 to 80% of our projects, we are carrying out SPT energy measurement in-house for the customer, and we are correcting the N values to N60. So this is important because, again, the backdrop is that the N value which we're supposed to use in analysis is N60. That's what all the correlations tell us. 60 standing for 60% of the potential energy should be transferred to the soil. Problem is we never bothered to measure it, so we never knew what our energy transfer ratio is. Now that we are measuring it, for example, we are able to correct these red field end values to get corrected N60 values on site. And this is very powerful because if you are able to correct your N60, your SPT values to N60, not only do you homogenize data collected by different types of SPT equipment, you also get, you reduce the scatter in your SPTN values. Sometimes the scatter was simply because of the nature of the test itself. And also, I think we also managed to somewhat increase the reliability of SPT measurements. And that, if you're using SPT as your sole tool for deciding what is the net allowable bearing pressure, then I think it has a direct correlation, right? So an SPTN value of 10 might give you, say, 100 kPa net allowable bearing pressure. You change that by just 30%, and your net allowable bearing pressure changes by 50%, right? So for small foundations, or for any kind of foundations, actually, I think energy corrections is something which should be mandatory. So that's SPT. I'm going to jump into rock drilling. So sometimes we have sites, high-rise buildings, specifically in this case, where the buildings are bearing on rock. In Delhi, for example, we have highly fractured and highly variable kind of quartzitic rock, which is hard to characterize at times. For rock drilling, we strongly recommend always the use of hydraulic core drilling rigs only, with double or preferably triple tube core barrel for proper characterization of the rock. We do not recommend the use of locally made Calyx kind of drill rigs, which we feel and we have observed give incorrect rock core data and over-conservative foundation analysis. And obviously, these kind of rigs, which are automatic or semi-automatic drilling rigs, are better, not only in terms of progress, but also more importantly, in terms of quality of the rock cores which we get. Just a quick why or quick answer to why we should do this. This is an example where we did a confirmatory test at the site this is near the Tapi River for the bridge project, actually, where if you look at these blue line dots or this blue series, so this was the core recovery and the RQD values which we got when someone used, not us, someone used the Calyx drilling rig with a single tube core barrel. And based on this, obviously they had designed huge, bridge foundations based on the soil report. When Cengrs went back and we reinvestigated the site using hydraulic rigs and triple tube core barrel, the actual core recoveries and RQD values were substantially higher, right? And I want to break it up in terms of what this means to the customer. I'm not going to go through this slide, obviously, but suffices to say that simply by changing your approach, simply by changing your tools and tackles, we managed to save the customer almost 2 crores in foundation cost alone. And the cost of the investigation was less than 15 lakhs. So that is, we like to say it's a 1200% return on investment. Just the only thing is to have that knowledge, to have that awareness, to do the right thing. So that's rock drilling. I quickly want to talk about in situ testing. This is one of my favorite slides from Professor Main, and which I borrowed from him. So people, very often, and we need to dispel this, right? So a lot of people, when they think about geotechnical investigations, they think about boreholes. And we are really trying to get people to move away from this archaic thinking that, and tell people that, geotechnical investigation is not the same as borehole investigation. So, it's like saying that, a surgeon will just be given a hammer to carry out the surgery. That's not the case. So there is a wide array of tests, of tools which are available to us as geotechnical engineers. All of these tools are available to us. And each of these tools, just like gardening or surgery, each of these tools has its own strengths and weaknesses, its own pros and cons, its own applicability. And this is why it's very important. We always say that when you have a project, it's important to spend a lot of time right in the beginning to sit down with the design team and figure out the optimum scope of the investigation in such a way that you use a variety of tools in an intelligent fashion to really get the parameters that we want for foundation, for ground characterization, and for foundation design. So important to do this not only to shut our eyes and do a copy-paste job and do a running meters job. It's important to actually do intelligent geotechnical investigations. It doesn't cost us anything extra to use our intelligence, but there can be tremendous saving for the customer. One such tool is the electrical cone penetration test with pore pressure measurement, or the CPT. Actually, the CPTU, U standing is because of the pore pressure measurement. The piezo cone this is what the piezo cone looks like. It's fairly straightforward. You have a cone, so we have pushers like this, which push a fully instrumented cone directly into the ground. The cone has got various sensors at the cone tip level along the sleeve and so on and so forth to measure the cone tip resistance, sleeve friction. It also has sensors to measure the depth, inclination, pore pressure. Sometimes it has geophones inside to measure the seismic wave arrival as well. So CPT is, this is what CPT is. I will not go into details. It does have a limitation. CPT, I think, apart from the fact that it's very expensive because it's not yet manufactured in India and requires some skill to operate. I think possibly the only limitation of CPT, or the limiting factor, is that CPT cannot be used in rock or in boulder kind of formations. It's largely a good tool, or a great tool rather, to use where you have overburden or where you have soil. That said, the advantages of CPT are, I do believe, far outweigh the disadvantages. We like to say cheaper, faster, better. And we'll see how that is. It's not only fast, it's very granular, accurate, versatile. It can go up to deep depths. You can test, and reliably, it is safe, clean, cost effective. Let's look at this in terms, when I say faster, how fast is, there's a quick example. If you do a borehole of say 30 meters, typical turnaround time, including rig shifting, drilling, sample transport, lab testing, report compilation, so on and so forth, is from 0 to report time is minimum 15 to 30 days is what you would take for a borehole investigation before you can get the results in. In a CPT, if you do a CPT sounding to 30 meters, essentially you can complete a CPT in just about 2 or 3 hours, and you can have a report in your hand in 4 to 5 hours time. In today's fast-paced environment, I think if we can save time for investigations, then I think that's useful, that's very powerful, because then you get more time for design, you get more time for construction. Of course, the CPT is far more accurate as compared to conventional borehole investigations. While borehole investigations, we get data points every 1.5 or 3 meter intervals where we do SPT and collect samples. In a CPT, because it's digital, you are getting a continuous profiling of the ground. You have data points every 2 centimeters. And that's good because even if you have a thin seam at any depth, you are able to very accurately catch that during your investigations, which typically would otherwise be missed in a borehole kind of investigation program. It's also highly repeatable, and I love this about the CPT. So essentially, if you do a CPT at the same location, you do a bunch of CPTs, you will almost always get exactly the same data. Something which we could not even imagine when we are doing boreholes. You do 2 boreholes at the same location, you'll usually get around a 20-25% variance in the SPTN values. In CPT, I think the fact that it's repeatable to the extent of 0.1% of the full-scale output, I think this is very powerful because this gives a lot of confidence to the geotechnical designer, because you know that you are getting data which is consistent, repeatable, and highly representative of the actual ground conditions. This is a typical CPT data, and you'll see how you also get, since it's software driven from Robertson's charts, you will also get your soil type or your soil behavior type from CPT. We have done this, we've done thousands of CPTs now, and we've compared with physical classification from boreholes, and we have found that usually the soil behavior type which you get from CPT is fairly bang on as compared to what you get from borehole investigations. There's another thing, right? So it's also the versatility of the test itself. So while, if you want parameters, while you have to do a host of other tests, If you don't have time, you don't have the budget, you can actually push a cone into the ground and you can get most of these parameters fairly accurately, a fairly good handle of all of these various soil parameters in a single push. So very versatile, very powerful for pre-bid preliminary investigations, also very useful tool for detailed and confirmatory level investigation. Since we're measuring pore pressures, you can actually get a fairly good idea of what is the hydrostatic pressure when you push a cone into the ground. You can also stop the cone and you can carry out dissipation tests, and that's very powerful for if you want to understand the compressibility of the ground, or you want to understand the hydraulic parameters, the permeability of the soil surrounding the cone. I would like to point out, since this is an in situ test, the quality of consolidation and permeability data which you get from a CPT, I really feel is far better as compared to what we get when we withdraw a sample and so-called undisturbed sample from a borehole, take it back to a lab, and put it in an odometer or a consolidometer, and we test. I really feel that the in situ testing gives us much better characterization in terms of compressibility and permeability. Common complaint used to be that you can't take samples in CPT. For some reason, many people still wanted to physically see samples before they take a decision. So we also added capability to collect soil samples using the CPT equipment itself. So now we have a push sampler which can actually be used. So there's a dummy cone with a push sampler, sort of like a piston sampler, which can be pushed into the ground, and we are able to collect samples, physical samples of the soil at discrete depths. This is fairly useful if you don't have a drilling rig at site, you just have a CPT rig. Very useful because then you are able to now collect a few samples, carry out a few confirmatory tests in the lab, check your classification, and so on and so forth. So very good for, again, where you don't have a drill rig at site. So that's about CPT. I'm not going too much into depth, just trying to give you an overview of these test methods. Pressure meter test is another favorite. If you go to France, most of the investigations are done using the pressure meter, and that's where we got our equipment from. This is a Menard pressure meter, which you see here in the photograph. So the pressure meter is fairly straightforward. You essentially make a borehole, and you lower the pressure meter probe at a specified depth. Once you lower the probe, I don't have a photo here, but once you lower the probe into the ground at a specified depth into a test pocket, and you expand the probe, you measure the pressure and the volume change, right? And this is the kind of graph that you get. Now, I want to talk about why this is important. I want to just sidestep, why this is so exciting, because if you really look at high-rise buildings, so you have the strength criteria and the stiffness criteria, or the shear and settlement criteria for design. Most large-sized rafts are unlikely to fail in shear, right? So we never really go up to the full ultimate strength of the soil. What we are working the serviceability criteria. We look at the settlement criteria, and when you look at that, the key performance parameter of the ground, which we're trying to decipher from our investigation program, is we're trying to understand what is the stiffness profile of the ground, right? And think about this. When we talk about stiffness, when we do an SPT based analysis or based investigation, we don't really measure stiffness in situ, right? So what we measure is we get the SPTN values, and then we use one of hundreds of empirical correlations to get some kind of an estimate of the elastic modulus of the soil. Okay? So something like this. You use a different correlation, maybe you get a graph like this. But when you carry out in situ tests, you do a direct capture of the stiffness profile of the ground. So when you do a CPT, of course, the CPT is data is empirically correlated to the elastic modulus. So you get a modulus profile from CPT. You also get, from the slope of the pressure volume graph, you also get a direct measurement of the horizontal stiffness of the soil. So the green triangles here is the stiffness profile which we get from pressure meters. I wanted to keep this slide in mind because this kind of the stiffness characterization is really the heart of what we are calling gold level geotechnics. And you will note here that the stiffness characterization from in situ testing is roughly 3 to 4 times higher as compared to what we believed the stiffness of the ground was when we were using empirical correlations based on SPT. Before that, I want to also talk about shear wave velocity. It's fairly common today in most infrastructure projects. In building projects, not so much. In high-rise projects, these days, shear wave velocity tests are being carried out. And I think once the new 1893 code comes out, this would become an everyday test for us. So it's good for us to understand. I'm going to talk about only two kinds of, there are many tests available to us for deciding for determination of shear wave velocity profile. I want to talk about two of these. The first is a cross-hole seismic test. I think this is the gold standard for a test in the world for accurate determination of shear wave velocity profile. The test is fairly straightforward. We make 3 boreholes typically, 1 source and 2 receivers. Once the borehole is drilled, it's cased, and the annular space between the casing and the ground is grouted bottom up. And once you do that and the grout sets, you can actually go back to the site with this kind of equipment. You lower typically a source, which would be usually an electromagnetic kind of source triggered from the ground. You lower a source into the first borehole. You lower these triaxial geophones into the other 2 boreholes. The concept is very straightforward. It's obviously when you generate the seismic waves at the source, and you catch them at the geophone locations, the velocity calculation is very simple. It's velocity is distance by time. So assuming you know the distance between the source and the receiver, you can actually divide that distance by the time it takes for the compression and shear waves to go from the source to the receiver. And with that, you get the compression and shear wave velocities. This is what I mentioned is, the 1893, which is currently under wide circulation. It will, once it comes into effect, we will need to determine the average shear wave velocity in the top 30 meters below the foundation level. And based on that, we will have to decide the site class. I also want to point out when we talk about crosshole, something which we miss sometimes is borehole deviation survey. I'm pointing out to ASTM D4428, which is what we follow, the standard we follow for crosshole, which recommends or which almost mandates carrying out a borehole deviation survey. So what is a borehole deviation survey and why it's important? I'll get into that. Before that, this is what the crosshole seismic test results look like. So you get your shear and compression wave velocity profiles. Based on that, you can actually compute your dynamic Young's modulus and your dynamic bulk modulus profiles, as well as your dynamic soil parameters. I want to point out the reason why we are carrying out crosshole seismic tests right now is for this. Right? So when we get the dynamic Young's modulus profile, this is very powerful because this is sort of exactly Gmax. So this is actually the low strain, the dynamic modulus is the low strain dynamic modulus, the elastic modulus of the soil. If you look at any degradation curve, so this is typically at very low strain levels, but if you degrade this modulus down to the strain level of interest, typically 2 to 3%, you can actually get a fairly good handle of what would be the equivalent static Young's modulus at the strain levels of interest. So we typically do this, we degrade this modulus down to our, our design strain levels, and we compare always the modulus value with what the modulus values which we got from CPT and from pressure meter, and also from lab testing and empirical correlations. So again, all of this effort goes in one direction. Again and again, we are trying to understand the stiffness profile of the ground so we can do serviceability or performance-based design better. I talked about borehole deviation survey, and why that's important is borehole deviation survey is very straightforward. You put an inclinometer in between the source and the receivers, and essentially the objective of carrying out a deviation survey is to actually measure the distance between the source and the receiver at various depths to get that distance profile. And that's obvious because when we did the crosshole here, right? So we were measuring the time of arrival in microseconds. Right? But if you don't know the distance between the two boreholes with depth, then all our computations are essentially wrong. So you can't just put a tape measure at the ground level and measure it as 3 meters and use 3 meters, as the distance traveled by the wave at depth. It's simply going to be wrong, and all of this time and money which we've invested in crosshole would be wasted. So deviation survey, I think if you're carrying out crosshole, always remember that borehole deviation survey is a must to get proper, crosshole seismic test results. The second test, so I'm a huge fan of crosshole seismic. We've been doing it, I think, for 15, 20 years now, and we do it in-house with our own equipment. The only problem with crosshole is it's expensive. It's really expensive because you have to make 3 boreholes, you have to grout it, and you have to carry out this test at site. The second problem is it takes a lot of time. So between drilling, grouting, grout setting, testing, typically 25 to 30 days is the turnaround time for getting my shear wave velocity profile. And that's fine it's a good investment if you have a critical project, a refinery, a power plant. Definitely, by all means, we should do it. But in some cases, maybe where we need a quick estimate of shear wave velocity, the other solution which we offer is the seismic CPT. And remember, we talked about the cone penetration test. We also have a different module now, which is known as a seismic cone. And a seismic cone is essentially a piezo cone. So it's measuring the cone tip resistance, friction ratio, pore pressure, inclination, depth, right? All the usual stuff. In addition to that, there is a seismic module, which is a follower attached to this cone, which also has got geophones built into it. And that's powerful because now what we can do is we can actually do a CPT. We can stop the seismic cone at a certain depth. We can use a ground source for seismic wave generation. And we can actually carry out sort of a downhole seismic test. So we can actually carry out a downhole seismic test using the seismic cone. So you know the distance traveled by the wave, you have the time that it takes, and you can get a fairly quick determination of shear wave velocity profile using a seismic cone. And personally, the reason I'm very fond of this is not only because it's cheaper and faster, that's for the customers to enjoy, but for us, I think what I really enjoy is the quality of seismograms which you get in a seismic CPT. And we bought this a couple of months ago, so we are still playing with it. The quality of seismograms which we get. So this is the seismic cone, right? So this is a seismic cone with the seismic module follow-up on it. And the quality of seismograms which you get on it, the quality of data is tremendous because there is no disturbance to the ground. There is no requirement of boreholes and casing and grouting. So since it's a direct push method, you get very good quality waveforms, which makes it possible for us to have very confident, very accurate picks for compression and shear waves. The only limitation of seismic cone, of course, is you can't do this where you have very hard strata, where you have rock. In those cases, obviously, you have to go back to borehole investigation techniques. I'm going to skip this slide. So we talked about different techniques. I want to wrap it up by talking about foundation testing. Obviously, no matter how much investigation and good design you do, we always like to say there's absolutely no point if we cannot translate a design onto the ground. So it's very important for the geotechnical and structural engineer to work together during the design and construction phases. Often the geotech engineer is forgotten after the soil report is issued, and this is not a good trend. We encourage customers to involve us all through until the foundations are done and dusted. Very important to carry out third-party foundation testing at your site. Not a good idea to put it in the scope of the piling contractor. Always better that the owner should get the QA/QC done third party for his project. And obviously, instrumentation is always a great idea for projects. These days, we have so many options for instrumentation. Let's take advantage of that. It's 5:45, so I'll quickly show you a case study. Pranav, how much time do I have approximately?
Maybe last 5 minutes.
Oh yeah, so I'll breeze through this. This is a group housing project in Sector 104, Gurgaon, which we concluded a couple of months back. These are 5 high-end towers, 40-storied, and some 2 towers of 30 stories and 3 basements. And also there's some commercial building and so on and so forth. So we carried out, as we said before, where the customer wanted us to do like some 20-25 boreholes. We went back to the customer and we said, hey, maybe you reduce the number of boreholes that you do. We don't need so many boreholes. And we took some of that money and we spent it in SPT energy measurements, in CPTU, in pressure meters, and cross-hole seismic tests. This is the layout of the tower, plan of field investigation. This is the borehole data. We did SPT energy measurement. Quickly look at what you get is the ETR value when we use standard automatic trip hammer mechanism. Is the ETR value is around 73%. It's fairly consistent, which is nice for 4 different rigs. We got fairly consistent ETR values. And with this, essentially what this means is you are able to bump up your SPTN values by a factor of 73 divided by 60, right? So we managed to correct the N values from 60. So this is the first level of improvement. We did CPTs. We got some CPT data. We always have a lot of fun with CPT because when we're doing a bunch of tests, we get to cross-correlate what we get from boreholes and what we get from CPT. So this is standard. We now have a huge data of, I think, over 1,000 CPTs, which we have correlated with borehole data. And so we're always amazed to see how well it correlates. You look at the SPT N60 value based on CPT and how well it is matching what we get from the adjoining boreholes. Shear strength, same condition, how the predicted shear strength values from CPT are matching what we get from the lab. Friction angle, unit weight, and so on. I don't have time to go into this, would have loved to, but this is the CPT results. Also, I want to point out this is we also get shear wave velocity from CPT, and we cross-correlated that with what we got from cross-hole seismic tests at the site, and you see how good the correlations are. So maybe the topic of a long discussion, but for now, I want you to take away that all of these different approaches, as long as different stories tell the same story and things match, I think geotechnical engineers can go to sleep and sleep easy. So that's a pressure meter test in progress at site. This is a hydraulic drilling rig right here. Pressure meter equipment, pressure meter results. So we get the limit pressure profile, we get the deformation modulus. I want to point out we also use pressure meter data to calculate the horizontal stresses at the site. And these days where we have basements, multiple basements in most high-rise buildings, also very powerful because this is the only way you can actually measure or you can compute the horizontal stresses, which are ground stresses, which will act on the retention system and on the diaphragm walls. So very good input for design of the underground retention systems as well. That's a cross-hole seismic test going on at this site. Again, we got the wave velocity, dynamic modulus. And this is what we were talking about. This is, sorry, not very good looking graph, but this is the stiffness profile. So see the yellow line here is the stiffness profile, which we get based on SPT using Bowles correlation. This is another correlation based on SPT, some Japanese correlation. And these plots, these are the stiffness profiles which we get from CPT, from cross-hole seismic, and from pressure meter, right? And this so we select the design profile based on advanced testing. We are able to select a better stiffness profile, which is, as you see here, typically around 50% higher than what we could select based on conventional testing. And that makes my foundation analysis all the better, right? So we did a quick comparison between, for example, for raft bearing at 12 meters, wherein my basic testing means borehole based or SPT based predictions. We got bearing capacity, shear criterion of just 42 tons. We managed to recommend as much as 81 tons, so almost double the SBC. Remember, SBC is safe bearing capacity, which is shear criterion. So we could justify almost 2 times, almost double SBC values. In terms of net bearing pressures, settlement criteria, at the same depth, we could, in place of 29 tons per square meter, which we got from boreholes, we could justify the use of 65 tons per square meter for the same foundation at the same location. You see how powerful that is, because you are able to bump up your net allowable bearing pressures by almost 110 to 130%. At the same time, it's the same story for piles as well, where our earlier calculations based on 2911, based on C5 method, we could compute 286 tons. Now we were able to compute 504 tons, so 76% increase in safe pile capacities as well. So that's for us, right? What this means for the customer, I took some help from my friend who's a structural engineer. And for this project, he actually calculated what this means in terms of cost saving, right? Because end of the day, the buck stops with cost of the project. So where basic geotechnical testing or borehole testing would, we got an SBC of 34 tons per square meter. The cost of the foundations was around, I don't have a total cost, it will come in the next slide. So he had originally planned pile foundations based on the original testing. And this is a true story because he actually got a soil report done where the customer is willing to go with 200 piles per tower, and the budgeting was all done. When we came back and we did advanced testing, we managed to eliminate piles altogether, and we managed to give a design which is based on simple raft foundations. The cost saving of this exercise, while maybe the spend on advanced investigation was around 45 lakhs, still a large number. And I remember the customer also balked when we gave him this cost. But then when we finished the work after 2 months and we came back to the customer, we actually managed to show him that he saved more than 16 crores in material cost of foundations alone, right? And that's a 3,600% return on investment. So we started doing these things because we realized that this is the language that customers understand, right? And where 16 crores is a cost of material cost. If you start adding the saving in the foundation construction time of more than 3 months, if you start talking about reduced carbon footprint and saving in overhead, etc., the cost saving effectively for the customer is upward of 40 to 50 crores, right? And so that's huge cost saving for the client. I don't have time for a case study too. I just want to point out one thing. We've done a lot of these projects now. What we did not do in the last project, and we did here in this project, is we also carried out a footing load test, and just on a 2x2 size footing. So we are doing these things also, and we are checking, what the settlement predictions based on model tests at site. We are checking it against what we get from our theoretical estimates, and we did find that even the model tests at site, the test results match what we get from advanced testing quite well. I want to close this with the last 2 slides. One, I think we've carried out around 25, 30 high-rise building projects in the last year and a half alone. I'm still in the process of putting the results together, but I just want to share, 4 different case studies, just so you don't think that this is something which is anomalous, the results which I showed. So consistently we are getting, when we do better investigations, we are consistently getting better, safe bearing capacities, better net bearing pressures in almost all cases. So better testing, better design. So that's my conclusion right there. I'm going to close with this slide. Obviously, in situ testing using advanced technologies is becoming not only increasingly more important, I think we are also becoming more aware of these kind of techniques and becoming more popular as compared to just conventional borehole and lab testing results. We do encourage everyone to invest in gold level techniques, gold level geotechnics for critical projects, not only high-rise buildings, but also refineries, power plants, highways, you name it, right? It's the same thing. And that's important for improving not only the safety of the foundations of the structures, but also to improve the foundation performance. Case studies have shown 50 to 150% increase in SBC values based on gold level techniques. And this translates in terms of money for the client, translates to an ROI in the range of 3,000 to 4,000%. So this is essentially free, right? This is no longer an expense or a cost to the customer. What customers have to understand and what project decision makers have to understand is that investigation is no longer an expense, it's an investment. Optimum foundation performance requires a change in approach, and that's what we are trying to do. Starting with site-specific ground investigation scope, not a copy-paste scope, where we take a BOQ and we paste it onto the project. Let's move away from that kind of regressive thinking, and let's discuss our project requirements, and let's use our intelligence in the beginning to work out a tailor-made, customized scope of the investigation for that project, for the ground conditions, and depending on what we're looking for. Gold level geotechnical investigations, as you saw, are very useful. And once again, you get what you pay for. So if you pay a little more, you invest a little more in investigations, you will definitely get what you pay for. Performance-based geotechnical design is very important, including soil structure interaction. You must design properly before you get into construction mode and you start making. Lastly, third-party QA/QC and proper ground instrumentation, foundation instrumentation is very important for realizing the design on the ground. Let's not depend on contractors who we have selected on L1 basis. Again, I think a different approach, this kind of a 360-degree approach, I think would go miles in advancing our country to the next millennium. Thank you so much for your time. I want to end here. Pranav, over to you.
Thank you so much, Sorabh sir, for the wonderful and kind of dynamic presentation. And we can understand that from the number of questions, those are flooded in the Q&A box, even before the start of Q&A session. So I request all the participants, if you have any questions, please put it in the Q&A box and we'll take it now. So yeah, as we are already running late, I'll just get started with the questions.
Wow.
First is a compliment from Dr. Sunil Basarkar, nice presentation. And then the second is his question, why we speak of gold level investigations and not platinum level? Is the scope of services to include design and optimization preventing to reach this level?
Yeah, that's a very good question, Basarkar sir. We always like to say, let's try to go step by step. If we go from bronze to platinum, we'll probably trip on our feet. Obviously, that's the future. And several projects actually we moved to platinum as well. When we say platinum, it's essentially the same thing, except I think the project has to deserve the level of effort and investment required in platinum level investigations. You need the right contractors for it as well. Primarily, better geotechnics, better investigations, of course, but also better, stronger instrumentation and stronger QA/QC of foundation. So I think right now you are aware of this, Dr. Basarkar. We have a very fragmented industry where different people are doing different things. So someone decides the scope of investigation, someone else carries out the investigation. Sometimes the third guy will actually interpret the results. A fourth guy will do the foundations, and a fifth guy hired by someone will do the foundation testing. So I think what we really would like to see in the future is, sew all of this together and kind of join all these elements together, because this is all geotechnical engineering, and have a single point responsibility and single point, responsibility for all of these points. And that eventually would be a platinum level investigation, I hope.
Yeah. So second question from Mr. Abhijit Kanungu, highly informative presentation. When two CPT 1 meter apart was shown in the slide, there was mention of glycerin and silicon oil. Can you please confirm what is the use of the same in CPT?
Abhijit, great question. Even I didn't notice that. The glycerin and silicon oil is, this slide is borrowed from Dr. Peter Robertson. So in that slide, he was actually talking about the use of glycerin and silicon oil for saturating the pore pressure, the filter. So, you have a filter element for measuring pore pressure, which is just behind the cone. So that filter has to be saturated every time, just so you saturate your filter in a direct show test, right? So that saturation, he was trying to compare what you get when you saturate using glycerin or when you saturate using silicone oil. That's all. So very minor, nothing to do with the test results per se. Good question. Good catch.
Another one from KVS. The geotechnical investigation is a combination of many testing and is phased to get good understanding of site characterization in terms of layer formation and engineering characteristics. However, your presentation shows more emphasis on CPTU. In my opinion, the engineer should take a decision based on more test data getting from phased investigation, need to educate clients to go with phased investigation than completing the investigation in a single stage.
I'm completely aligned with you, KV sir. I think I'm sorry if there seemed to be a bias on CPT in my presentation. I think it's simply because I'm more excited about this right now, that there is some apparent bias. Where this is a new technology which we're trying to promote, and I am personally very excited about it. Aside from that, I'm 110% aligned with you when we talk about tailor-made investigation programs. I do believe that single-shot investigations is silly. We phased investigation, carry out a pre-bid or a preliminary investigation, use that data, understand the geotechnical challenges likely at that site, and use that information. In fact, combine it with the desktop study as well, and then use that information to sit down with the design team and actually model or design your investigation program in a very intelligent fashion, so we get what we're looking for. So it's not just CPTs. If you saw the entirety of the presentation, we are very strong about not only different phases of investigation, but also about using multiple approaches on the same project, so we can actually cross-correlate parameters and cross-correlate predictions based on different tests, and that will increase designer confidence in the results.
Another one from Dr. Basarkar. SPT energy correction is measured at the anvil level. It cannot measure energy losses due to a damaged sampler. So can we say that the current method of energy measurement has limitations?
I'm not very sure about this, Basarkar sir. I would need to think about this and get back to you, and I will. I think my understanding, and maybe if Dr. Partha is still there, maybe he can pitch in. But my understanding is that I think it would capture the damage sampler as well, because just like a PDA test or a high strain dynamic pilot load test, it's the same principle of wave mechanics, right? So what the energy measurement which we are doing is based on the upward traveling wave, which also takes information from down from the sampler through the soil and upwards. So I think that information is captured in the data when we carry out the SPT energy measurement. But if Dr. Partha is there, I would love some help on this question.
Yeah, Dr. Partha Sathi is there. Probably he's typing answers.
No problem. Otherwise, we'll get back to you, Dr. Basarkar, on this.
Yeah. So next one again from KVS sir. Though procedure is available to convert the ETR to 60% from other ETR value, why don't you convert your machines to get ETR 60% directly? This is better than converting using energy ratio to get SPT 60%. Some sites we found the converting SPT to 60% ETR from other ETR is not correct.
I think it is. It's like a calibration process, right? So I think correcting or converting rigs to get exactly 60% ATR is typically hard. Oh, sorry. I think Dr. Partha might want to pitch in for Dr. Basarkar. Dr. Partha?
Yeah, the first question of Dr. Basarkar, the sampler damage,
Yes.
I think it's a prerequisite to have a good sampler. Cannot have a damaged sampler. So therefore, the energy transferred also is irrelevant, and the test itself is irrelevant. As a procedure, I think we need to have several shoes on backup and standby, because going through the ground, there are several gravels and pebbles that will tend to damage the sampler, and if the sampler at the bottom is damaged, better to replace it. So you can't correct it, and therefore the test itself is invalid. So I didn't get the second question. What was the second question?
No. Actually, his real question was that if you have a damaged sampler, will it change the ATR value which we measured? So is the SPT energy results, are they affected by the sampler use?
No. When the N value itself is irrelevant, then the energy measurement also is not relevant.
Okay, got it. Okay, that's an easier answer. I was trying to go into the wave mechanics. Okay.
Thank you so much, Dr. Partha Sathi.
Thank you so much.
There are so many questions. I may have to skip a few. One question
Yeah,
from
just to compliment
anonymous.
Pranav,
Yeah.
Sorabh, fantastic gold level presentation. You nicely touched upon all the institute test and showing a lot of data. Really appreciate. And one thing also I learned is the high-rise code that 16700. I think I will be excited to go and look at in detail because I think it just released last year. Thank you for that.
Yes. Thank you, sir.
So next one, how do you make a decision on spacing of borehole required for a site? Is there any relation between site size and the number of boreholes apart from economy?
Yeah, I think economy should be the last deciding factor when we decide the scope of investigation. Really speaking, you're only spending these in Indian conditions, we are spending less than 0.3% of the cost of the project, not even that much on investigation. So I think economy should not figure on this decision. Unfortunately, it does. The decision on spacing of the borehole is really a decision which has to be taken very on a project basis. So I don't want to give anyone formula or regulation for this. It depends on what you're building, where you're building it, what are the anticipated ground conditions. So if you have if you anticipate a lot of lateral variations at the site or a lot of vertical variations at the site, obviously increase the number of test points. If you have consistent geology, you can get away by doing fewer boreholes. So really, this is a call that we have to take on site per site basis. That said, I would welcome anonymous attendee to look at 1892. So the new code, I think 2021, there's actually a table which gives some rough guidelines on the number of boreholes or on the spacing of boreholes, which you should ideally include in your program, depending on what you're building. So depending on whether it's a linear project or a tall building. So I already mentioned for tall buildings, you have to have 3 test points per tower and 40 to 50 meter grid spacing boreholes in the non-tower area. So similarly, it gives some guidelines. I do recommend not to get married to the guidelines, use them as guidelines and decide your investigation program on case-by-case basis. If you can't decide, at Cengrs, sorry, I want to say this, we have a program which we call a mafia offer, where we welcome anyone to just email us project details and site location. And we have a team of people who sit and who develop your scope of investigation free of cost. So that's a service which we have started. We don't charge anything from it. We don't expect anything from it, but something which we have started because we're passionate about it.
Maybe we'll take the last question due to the time. And it's from engineer Avik Kumar Mandal. What can be the good or optimum combination of various field investigations involving exploration of boreholes and other in situ tests and laboratory tests of collected samples of geomaterial for various type of projects for technically sound as well as economical design?
Engineer Mandal, it's again a great question, and we get these questions all the time. I'm very hesitant to give one formula because really there is no one formula or there is no copy-paste solution for deciding investigation program scope, and which is why we started this the mafia offer thing, because really, I mean, you have to decide. So if you have soft ground conditions, then doing CPT and all that is useless. If you have rock at a site at shallow depths, then you can't do CPTs. Then you have to use a different approach. Maybe go towards, obviously rock core drilling, proper core drilling, maybe some pressure meters in the case of weak rocks. It really depends on the ground conditions, really depends on what you're building, what kind of parameters we are looking for. I don't want to generalize the combination. We have to look at it on project by project basis. There is no shortcut.
We will limit today's Q&A session at this point. We have few more observations,
Yes.
But if any of you have any other question, you can reach out to Mr. Sorabh directly. We'll share the web recording, and if anybody wants, you can reach out to me and get contact of Sorabh sir, or you can go to Cengrs website and check. So thank you so much, Mr. Sorabh Gupta sir, for delivering an excellent presentation in this webinar series. You have truly elevated the standard, and after these 2 webinars, we really have to think about the third one and the speaker that we get to match the level of first and second webinar. So thank you so much.
Thank you so much, Pranav, and thank you everyone for attending and sharing with us. Thank you so much.
Thank you.
Yeah, thank you, Dr. Parthasarathi. So this is the end of session 2. Thank you again, all of you, for attending, and join us back in our upcoming webinars. You'll see the details on our LinkedIn or e-blast that we send regularly. So follow us on the LinkedIn page for regular updates. Thank you so much.